Today we're looking at the test review. This is problems 1 through 6. These are all the graphing problems. If I say something's important, please write it down and remember it for the test, because these are the things that people need for the test. Either they lose points on it or they forget and switch things around. So I'm looking at graphing y equals log base 3 of x. When we graph logs, remember that we're going to do things a little backwards. So we're going to plug in -1, 0, 1 for the y, and I'm going to convert 3 to the y, convert this to 3 to the y equals x. Okay. So notice that I have, when I convert, remember that you're converting from a log to an exponential. So you need to remember some way of taking the pieces of the graph, or excuse me, of the equation, and putting them into their other format. Okay, I use the 2 cubed equals 8, and if I convert that, then I would have log base 2 of 8 equals 3. So let's move on and talk about plotting these points. If I put a -1 in for the y, I get 1/3, because remember we're talking about flipping that over. The negative exponent flips it over. It does not make it negative. And also, if you want to think reciprocal or inverse, that's fine too. Just make sure you don't make this number negative, because that will really mess up your graph. So that's actually very important. Do not make that number negative. A negative exponent only flips the fraction. Okay, so then I go 3 to the 0 equals 1, and 3 to the 1 equals 3. So I'm going to go plot those points. The asymptote that I have is going to be x equals 0. That's always for log. It's always a vertical line. And so just make sure you don't cross over the asymptote. Okay, so for number 2, we have y equals 3 to the x minus 1 plus 1. If you have a translation that that's in with the exponent here, just make sure that you notice that there's not going to be any parentheses there, but it still means that I'm shifting it right 1. In this case, I'm going to shift right 1 and up 1. This is an exponential, so I'm going to put -1, 0, 1 on the, plug it in for the x, and I'm taking out the translation because I'm going to do that later, so I'm just doing 3 to the x, which a -1 gives me 1/3, 0 is 1, and 1 gives me 3. If I go plot these points right here, I'm going to take the points and I'm going to shift them. Remember that you have an asymptote of y equals 0 right here, but the asymptote's going to change because you're going to shift everything up 1. So now your asymptote's going to be at y equals 1. Okay, now I'm going to shift the points right 1 and up 1. So that one shifts there, this one shifts to right here, and this one shifts to here. And now I'm going to draw my exponential graph, making sure that I don't cross the new asymptote. For number 3, we have y equals e to the x. Remember, e is, it's basically we've rounded it to 2.72. We are rounding the number so that we can graph it. And if we do e to the -1, we really get 1 over e. E to the 0 is 1, and e to the 1 is e. Okay, this one's going to be about, I'm going to graph at about 1/3, and this one is, I'm going to graph at about 2 3/4. Okay. With the exponentials that have an e in them, it's the same type of graph. It's still a growth. This is going to be a growth graph instead of decay. The asymptote is still at y equals 0 because I don't have any translation in this graph. So I just plot my points and draw my graph. Okay, the next graphing problem is y equals 1/3 to the x minus 3. So I have y equals 1/3 to the x. I'm going to take out the translation right here. And I have 3, 1, and 1/3. Notice that 1/3, when you flip that over, you get 3. 1/3 of the 0 is 1, and 1/3 to the 1 is 1/3. Okay, this is a decay graph. So here's the thing. I need to make sure that I am watching what this is supposed to look like. So I'm going to make sure this looks like a decay. The asymptote is y equals 0, but I'm going to shift it down 3. So now my asymptote is down at -3. This is the line I don't want to cross. So now I'm going to shift all my points down 3 and then draw my graph, just making sure that I don't cross the new asymptote line. All right, so for number 5, I have a natural log, which is y equals natural log of x plus 2. The translation is shifting everything up 2 because there's no parentheses around it. This is going to be on the outside of the x. Again, I'm going to do this backwards. I'm going to go ahead and plug in for y. So knowing that this is a base of e, I'm going to convert it to e to the y equals x. Okay, and then right here, I'm going to go ahead and go e to the -1 is 1 over e, e to the 0 is 1, and e to the 1 is e. Okay. Remember that this is the way the log is supposed to look, so I'm expecting the points to look this way. Okay. All right, so I plotted my points, and now I'm shifting them all up 2. Notice that my asymptote didn't change. If I had moved it, if it had had a shift to the right or to the left, then in this case the asymptote would change because it is a vertical line on a log. So right here, this is the line that I don't want to cross. It is not this line anymore. This asymptote is only for an exponential. This asymptote is for a log. It works that way all the time. The exponential has a horizontal asymptote. The log has a vertical asymptote. Okay. All right, let's do number 6. Okay, this is an exponential. I'm going to take out the 2. Because the 2 is in the exponent with the x, it is going to be a shift to the right. So I'm going to do that at the end. I went ahead and put in my -101 along with my numbers. This is around 1/3, so I'm plotting -1, 1/3. This is 1, and this is the e, or the 2.72, which is about 2 3/4. I'm going to shift everything to the right 2. My asymptote does not change. It's still at y equals 0. And then I'm going to draw my graph. Okay, so let's talk about some things that are very important for graphing. If you get these numbers wrong, or if you do a flip and you make this negative, the points are going to look a little different. All right, so just be careful of that. If it's a exponential and it's growth, it has to look like this. If it is a decay, then you need to know what the graph looks like there. So let's talk about that. If it's growth, it's going to look like this. So if you know it's a growth equation, then your graph should look like this for growth. Okay? Don't get confused. Well, the thing is, if you actually plot the wrong point, then it is going to be confusing. So if you know that it's decay, your graph should look like this. And if you know it's a log, your graph should look something like that. Okay, for the most part, those are the only ones that you're going to see that are weird in the test. Okay, now let's talk one more time about domain and range. So for instance, number 1 had no shift in it, okay, but it was a log. All right, the domain for this is going to be 0 to infinity. because of the fact that it has a vertical asymptote and it's at x equals 0. The range actually goes down the y-axis forever, and it's actually going to follow along the y-axis forever to infinity at the top. So this is going to be, okay, so for a log, the range is always negative infinity, positive infinity. For number 2, the domain and range are, domain is actually where it's going forever in both directions. So the domain is going to be negative infinity, positive infinity, but the range is different because it has an asymptote when it was shifted up 1. So if it's shifted up 1, but notice that it's not equal to 1. Notice that there's a parentheses for the 1, which means that it's not equal to, it just basically starts right after the 1. Okay? For number 3, we have the same thing. All right? However, the domain for number 3 is negative infinity, positive infinity. The range was not shifted, the asymptote was not shifted, so it really just starts at 0. Okay? All right, let's do, how about number 4? For number 4, it was shifted down 3. Okay? So it was shifted down 3. So basically, the domain again, since this is an exponential, the domain goes in both directions to infinity. The range is negative 3 to infinity. Okay. For number 5, it was shifted up 2. But the asymptote didn't change. It really doesn't change. The shift did not change anything. Okay. So the domain is 0 to infinity because on a log, the vertical asymptote is at 0, so it's only ever going to the right. For the range, this one is the one where it's infinity, negative infinity, positive infinity, because it's going up and down forever. Okay. For number 6, again, this one was actually shifted right too. So the asymptote didn't change. In other words, the domain is still negative infinity, positive infinity. The range did not change because it was never shifted up or down. So what you really have to do is look at where the asymptote is, okay? If the asymptote changes, then that domain or range will change, okay? Let me say that one more time. We're going to fix this one real quick. See, the range right here is 0 to infinity. Let's say this one more time. If it's a log, it's going to change, and the asymptote changes, it's going to change the domain. If it's an exponential, okay, let's do this right here so you can see it. That's a log where the domain changes. If it's a exponential and it's shifted up and down, then the range is going to change. Okay? So then you'll want to make sure you fix these numbers here. Otherwise, the other ones are all infinity, infinity. Okay? All right. Thanks for watching.